Welcome to Taxonomy Online Mathematics. Let's take the episode 3 of the circle theorem. We want to talk about the theorem 3. If you are new here and you've not subscribed, please subscribe to the channel. Like the video after you watch and you find it educative. Leave your comment and share with your colleagues or anybody who may need this. For the theorem number 3, we say that a diameter subtends an angle of 90 at the circumference. If you have a diameter, so per the definition, as I said, the angle a diameter subtends at the circumference of a circle is always what? 90. Or better still, we can say that the angle in a semicircle, we know if you have a circle, this is the center. We know diameter is a line that joins 2 points that pass through the center. So this is a diameter. The same time, this is a semicircle. These are the two semicircles that come together to form the circle. So any angle formed by this diameter is a right angle, meaning it is 90. Any angle, if I have it this way, and this is the center, so the angle here is also what? 90 degrees. So we can say this is a diameter subtending an angle at the circumference to be 90. This is a semicircle. An angle in a semicircle, which is at the circumference, is also what? 90 degrees. So if you have a question, as in this case, we can say if angle BAC is equals to 43 degrees, find angle BCA. So let's say we have a question like this. If the angle BAC is given to us as what? 43, it means here is going to be 43 degrees. Our task is to find the angle BCA. BCA, this angle here. Already we know that angles in a semicircle is what? 100 and what? It's 90 degrees. Therefore, the angle ABC is going to be 90 degrees. Angle ABC, this angle will be 90. From the plane geometry 1, we know that the sum of angles in a triangle add up to 180. So we can say that from our triangle ABC, if I add this angle, which is 43 degrees, plus the angle at the top, which is also 90 degrees, plus the angle I am asked to find, I am supposed to get what? 180 degrees. So fast forward. If you add this, we have 133. So 133 degrees plus the angle BCA equals to 180 degrees. So per our grouping of like terms, your angle BCA will just be 180 minus 133. And that will be 47, I guess. So we have 47 degrees. So it is not only that we have to be finding this, we can use that property to find other side. Let's take another question. Alright, so let's look at this. If the line AC is taken as a diameter of the circle, we have to find the value of x and what? Y. So this time around, we have other properties being included. We are going to take the chord BC. BC is a chord. How many angles is BC subtending or forming with the circumference? If you look at BC, there is an angle they form at what? 65 degrees. The same BC form the angle what? X. So we can go to the previous theorem, theorem 2, which says that a chord subtend an angle or equal angle at the circumference. An arc subtend a same arc, subtending the same angle. Those two angles are what? Equal. So I can say that x is going to be what? 65 degrees for the value of x, stating the theorem, which says that the angles subtended by a chord at the circumference are equal. Good. Then using line AC as what? A diameter will mean that the angle at B is going to be what? 90 degrees. So I will say that angle ABC will be 90 degrees based on the theorem, which says that angle produced by a diameter at the circumference is 90 degrees. Then from there I can say that from triangle ABC, the sum of the angles 65 degree plus the angle we just found 90 degree plus y should give us what? 180, the sum of angles in the triangle. Good. This will give us 155 degrees plus y 180. By grouping of like terms, we can have our y equals to 180 minus what? 155. So 180, 155 degree. So y is going to be 25. So this is going to be 25 degree. So if you know the theorem or the property, just by quoting them and equating them, you can easily get answers to questions on circle theorem. I believe you have a feel of this property 3. If that is clear for you, then give a thumbs up, share if you find somebody who may need this, and leave your comment as we get interactive. The next episode will take circle theorem 4. Thank you.